So this video is integrated 1, chapter 4, D-Day number 3. This is the one we did in class on paper. Just putting up a video for those of us who maybe were having some questions on it and didn't ask in class. So very first thing I'm going to do is I'm going to plot these points on this graph. Okay, so I am going to be looking at what my X is, and my X is grams of fat, and that's going to go on my X-axis, and my Y is going to be the amount of calories. So this right here is going to be grams of fat. And this right here is going to be amount of calories. So okay, now to scale this, for my X's, I want to try to figure out what's my max and min. So let's see, my minimum looks like 5 and my maximum's 31. So I need to get from 5 to 31. So let's see. For this, let's try having this be 5, 10, 15, 20, 25, 30, 35, 40. Now for my Y's, my minimum Y is 190 and my maximum Y is 540. So I need to get from 190 to 540. Okay, so I think what I am going to do is I am going to go and have this be 150, 200, okay, 300, 400, 500, 600. And so this will be 250, 350, 450, 550. Okay. And I'm going to plot these points. So I'm going to pause this and plot them. So here's my graph. I plotted those points. And now what I'm going to do is I'm going to get my data onto my calculator. Okay. So what you want to do is you want to make sure, because when your calculator is going to be given to you before the test, it's going to be reset. So what that means is your stat diagnostic will not be on. So to get to your stat diagnostics, we're going to go to mode and click mode. And we want to go down to the one that says stat diagnostics. Right now mine says off, I want it on. So I'm going to arrow down until I get to stat diagnostic. Okay, I'm going to arrow to on and hit on. Okay, now it's on. Now to put my data in, I'm going to go to stat. Okay, when I press stat, this is what I get. And I want edit, so I'm just going to hit enter. Okay, I already put my data in here. So I put my grams of fat in my, which was my X in my L1, and the other one in L2. Okay. Then what I want to do is, if I want to get the equation, I'm going to hit the stat button again. Okay. So again, I'm going to press stat. And when I press stat, this time I'm going to go to calculate. So I'm going to arrow over to calculate. And the one I want is number 4, linear regression. So I'm going to hit number 4. And if I want to have the equation in my calculator, store it, I'm going to stop here and I'm going to press the green alpha button and then the trace button for F4. And when I press it, I want Y1. I'm in my first graph. Hit enter, hit enter. And here it is giving us our equations, okay? So this is y equal ax plus b. So my a, which is this 12.73, is going to go with my x, plus my b, which is 146.97. Give me two numbers after the decimal. And I am going to put that over here where it says calculate the LSRL, okay? So I am going to write y equal, hold on, let me get this a little thinner. I'm going to calculate y equal, give two numbers after the decimal, so 12.73x plus 146.97. The other thing that I have here is the correlation coefficient. And the correlation coefficient is your R. Okay, so that's going to go here. So I'm looking at this R right here. Give four numbers after the decimal. So I'm going to write that here. So it's going to be 0.9054. Okay. Now, if I want to see the graph, okay, I need to make sure my stat plot's on. So if I do second and y equal, and make sure that the stat plot is on right now, mine is off. And to turn it on, I'm going to hit enter and click on, and it's on the one I want, which is scatter plot. Now to see the graph, I'm going to hit this zoom button, and the zoom I want, I get all these choices, is going to be number 9. And I can arrow down to it. I'm going to arrow down right now just so that you guys can see which one I'm on. I'm on this one, but I can really just press 9 and it'll take me right to it. And there's my graph. Okay. And I can kind of look at that compared to my graph that I had here. Now I actually had a different line on here because I had some other data in here. Let me just get rid of those. Okay. So let me do my graph again. Now I want us to accurately draw that line of best fit. So what I'm going to ask us to do is to give me 2 points. Okay. So, and we're going to plot those 2 points. So what I'm going to do is I am going to look here at my x's, which are basically I'm going from 0 to 40. I'm going to pick 2 x's that are reasonable. Okay. So since I'm going 5, 10, 15, 20, maybe I don't want to do like a 17 or an 18. So let's say I choose 10. Why? Because I'm just choosing 10. Okay, I just picked it. And I'm going to plug that into my calculator and get my output. Then let's say I choose another number here. So let's say, for the sake of argument, I do 40. Okay, let's say I do 40 and see what happens at 40. Okay, so I am going to put these into the equation. Okay, so I'm going to come back to my calculator. I'm going to type in 12.73 times, and I'm going to use parentheses for times 10 plus 146.97. I hit enter, and it's going to compute the y that goes with that x. So when I put in a 10, I get a 274.27. So that's going to be 1 point I'm going to plot. I'm going to hit on the calculator second, the second button, and the enter button for the word entry. And what that just did is it retyped it. So I don't have to type it all in again. And I just come here and change this 1 to a 4 for a 40, and then just hit enter. And that's 656. That's going to be, no, I can get 656 on that. So 656.17. Okay. So I am going to plot those 2 points, but I want to plot them maybe in a different color or circle them so I know that those points are not from my table, but from my equation. So I am going to plot 10, 274.27. So 10, this would be 250. This would be about 275. So it's just under 275. So let's say I drop it down a little bit. There you go. Then I'm going to do this 40, 656. So I'm going to go to 40 up to 600. This is 600. This would be 650. So 656 is going to be slightly above. There you go. There's my 2 points. Then I'm going to get a ruler if I'm doing this by hand and connect these 2 points. Okay. And let me just kind of adjust mine. I'll make it green. And I'll add arrows. And then that is my line of best fit. Again, I am using 2 points that I found from my actual equation to form my line. And how did I pick those 2 points? I chose an X that is in my interval here that I'm graphing, and I chose a second X. And then I put them into the equation that I just found, and then I worked it out. Okay. So let me put this aside for a second. So now the next thing, it's asking me to describe the scatter plot. Okay. First off, we see this is positive because it's increasing. If you really want to tell if this is how accurate it is, look at your R. Remember, R's need to go, are going to be between a -1 and 1. The closer they are to 1 or -1, the stronger the line. So 0.9 is pretty strong. So I am going to do my sentence frames here. Okay, so for this, I am going to say there is a, and we say strong or weak. I'm going to say strong, positive or negative. I'm going to say positive because my R is positive and it's also increasing. Both of those are going to be true. Linear relationship. And then from our sentence frame, they want us to state what the X and the Y are. The X is grams of fat. Okay, right here, grams of fat. And the Y is number of calories. I see it here, grams of fat, number of calories. So is a strong positive linear relationship between the number of grams of fat and the number of calories. Okay. Now interpret the slope. So when I'm looking to interpret the slope, this number right here in front of my X is my slope. Okay, that is my slope. When I'm looking to interpret the y-intercept, that number that doesn't have a X with it is my y-intercept. Okay, so I'm going to be using the 12.73. So I'm going to say on average, as the, and our X is grams of fat. Okay, so on average, as the grams of fat increases by 1, and I'll say 1 gram, and then I want my Y, and again, my Y is the number of calories. The number of calories, and then we're going to say either increases or decreasing depending on the line. And we see it's an increasing line, so we're going to say increasing. So number of calories increase by about, and again, I'm going to use my slope from my equation, And the slope for my equation is in green, that 12.73. So by about 12.73 calories. Then I'm going to do the same with my y-intercept. So for my y-intercept, when the, and I'm going to start with my x, which is when the grams of fat is 0, and then this is my y, the number of calories is about, and then my y-intercept is the one in pink here, 146.97. 146.97 calories. Now, when it says predict, okay, predict the amount of calories in your burger if you consume 16 grams, what I'm going to do is I am going to take my equation, okay, this one here. So let me just copy it down real quick. Y equal 12.73x, and instead of x, I'm going to put in 16 because I want 16 grams plus 146.97. And I'm going to put that in my calculator. And since I already have these equations in here, let me just get this refocused. Since I already have these equations in here, I'm going to hit second and enter. I'm going to retype it again. And I again have a 12.73. This time I want times 16 plus 146.97. I hit enter and I get 350.65. So this is going to equal 350. So 350.65 calories. Okay, then when it says calculate the residual, okay, the formula for residual is the following. So residual is when you take your actual minus predicted. And what we're basically trying to see is how far off is our equation from the real data. So when I'm talking actual, I'm talking about from the table. So we want to calculate the residual for the prediction. The prediction we were doing was 16 grams. Okay, so I want the residual for 16 grams. So I'm going to come up to the table and I'm going to find 16 grams. And for 16 grams of fat, we should have had 360 calories. So I'm going to put 360 calories here minus my predicted, and my predicted is the one I just found on letter G, which is 350.65. Okay. So I am going to take 360 minus, and I'm just going to come steal this from here. Okay, 360 minus 350.65. And I was off by 9.35 calories. It's CAL for calories. And I predicted the actual amount of calories was more than what I predicted. Okay, now on letter J, I am going to be doing another sentence frame. I'm going to be doing interpret the correlation coefficient, which is this. Okay, so I'm going to say since R is equal to 0.9054, okay, is, and I'm either going to say close to or far from 1 or -1. Now, since my R is positive, I compare it to 1. If my R had been negative, I would compare it to -1. So since R is equal to 0.9054 is, I'm going to say close to 1. There is a, and then we're going to say strong or weak. This is strong. Positive or negative. This is positive. Linear relationship between the number between the, I'll put grams of fat and the calories. Between the grams of fat and calories. I'm running out of space. I'm going to write calories going up the side. Or here, I'm going to write on the page. Well, I'll write it. And calories. Okay. Now, if I'm going to be adding on for extra credit, finding the biggest residual and finding the upper and lower bound. Okay. So if you want to do that part, if you go to Stat, Edit, okay, you come up to the top L3. I want to get List, and List is under Stat. Okay, it's on the Stat button. I'm going to press second and Stat. And you'll see number 7 is residuals. If you did not save or store your equation, you're not going to see that as an option. And then you see that I get, this one's, I was off by 31, by 20, by 9, by 1, by 35. Over here, we are off by 115. So that is going to be the 115 point, let's say 70. Okay, that is going to be my biggest residual. So I would take that 115.7. Okay, and this is just kind of a side note. I'm just going to do it here just on this paper for a second. So what I would do is I would take my equation, which was y equal, let me just get the equation back a second. Y equal 12.73x plus 146 point, let's see, I want to say 497. And what's going to happen is I am going to add and subtract that biggest residual. Okay, and that biggest residual, if I go back to my list, my biggest residual was this 115.7, 115.7. And when I add and subtract that, that's going to give me 2 equations. So when I add it in orange, my equation would be 12.73x. And let me just do the math real quick. 146.97 plus 115.7. I end up with a 262.67. When I am taking it off of that, so let me just get that again, and I'm going to change this to a minus. My lower bound would be 31.27. And this would be my upper bound equation. This would be my lower bound equation. Okay. If I had put it in here, 12.73x plus 262.67 and 12.73x plus 31.27. And if I hit graph, I'm going to see that's my upper bound and that's my lower bound. Okay. So let's say that I was saying, okay, for let's say 22 grams of fat, how many calories should it be? What would the range be? Okay. So say I'm saying 22 grams of fat. Okay. What would be a reasonable range? what would the range be, okay, of calories? What I could do on here is I would put 22 into both of these equations if I want to do it by hand, but I can also hit second and the trace button for calculate. Okay, so this button right here to get calculate. And if I hit value, I could put the 22 in. When I put 22 in, it's going to give me it first here on the original line. If I arrow up or down, so if I arrow down, it's going to give it to me on the second equation. So it's going to say, okay, that should be, let me just get this light on here. That should be about 542 calories. If I come down here, 311 calories. So it should be between 311 calories and 542 calories. Okay, that's the max and min that it should be. That's what the upper and lower bound range are used for. Okay, this would be extra credit on a test. Okay, so let me get back to the actual problems here. So if I come back to the back side of this worksheet, okay, the review problems. Multiplying this out, I'm going to do a box, the 2 by 2, because I have a binomial times a binomial, 2 terms times 2 terms. I'm going to put my minus right here in front of my 7, 4x, and put my plus in front of my 9, and then I'm going to multiply. So when I multiply this, I get a 12x squared, 4x times 3x is a 12x, 4x times a negative 7 is a negative 28x, 9 times 3x is a 27x, 9 times a negative 7 is a negative 63. And you don't leave your answer like this. You have to give it to me outside of the box and combine like terms. So I'm going to have a 12x squared. I'm going to have a negative x because the negative 28x and the 27x and a minus 63. And that is my answer. On number 2, I'm going to fraction bust. So I am going to multiply everything by 6. So I'm going to go 6 times 7 plus 6 times x over 6 and 6 times 10. And when I do that, I'm going to get a 42 plus, and here the 6 and 6 cancel out, I get an x equals, and 6 times 10 is 60. I'm going to minus 42. I'm going to minus 42. And I get x is equal to 18. And that's going to be my answer. Okay. On the next one, when I am solving this, I am going to distribute this negative to the 3 and to this negative 4y. So I'm going to have 8 minus 3, and a negative times a negative is a positive 4y equal 36. Now on this side of the equal, I have some like terms, the 8 and the minus and the negative 3. So 8 minus 3 is 5. So I have 5 plus 4y equals 36. Then I am going to try to get my 4y by itself. So I am going to minus 5, and I end up with 4y is equal to 31. Then I'm going to divide by 4. And when I do that, I'm going to get y is equal to 31 over 4. And you can leave your answer like that. Number 4, everything in here is going to be squared. When I square my 4, I get a 16. When I square my x cubed raised to the second power, power to power, I multiply. That's going to give me x to the 6. So I'm going to have an x to the 6. When I take my y to the 6 and raise that to the power 2, again, power to power, I multiply. So 6 times 2 is 12. So I get y to the 12. That is my answer, 16, because 4 squared is 4 times 4, x to the 6th, y to the 12th. On 5, I am going to put this negative 2 in for x. So it's 3 times negative 2 minus 7. So I get a negative 6 minus 7 And a -6 minus 7 is a -13. That is my answer. On number 6, I am going to be plotting this graph. I'm going to start with my y-intercept, which is -4. So I'm going to come down here to -4 on my y at that point. Then my slope, okay? My slope is really a 1, really a 1/1, which means up 1, right 1. That's what a slope of 1 means. So I am going to go up 1, right 1, up 1, right 1, up 1, right 1, and so forth. And then I'm going to connect this. And you don't just connect from here to here, for example. I want to go through this. I want to extend it, okay, in both directions. So let me actually grab this. Okay. And then that is going to be my line. So on this next one here, we want to try to identify these. Now, if it is negative, it should be a decreasing line. This one here is decreasing and the points are almost on it. So that's going to be my R being a -0.9. Okay. This one here is also decreasing, but the points aren't as tight. They're a little further off. So that would be my R being a -0.6. Then between these two, okay, now if I did not have the line over here, okay, if that line was not there, I don't know if I would know if this is increasing or decreasing if I did not see that line. Okay. Over here, this is kind of going in more of an upward direction where we can kind of see it's increasing. Again, if this line wasn't here, I probably wouldn't know. So I would say that this one here is almost 0, almost no correlation. So I'm going to say it's this one. And then this one here, obviously, is going to be the last one. But again, it's positive, so it has to be a positive R. And it follows it, okay? All the points are following it up a little bit better. And again, I can see that it is increasing where this one over here, if this line wasn't drawn here, maybe I'm going to draw the line straight across, okay? And think it's more horizontal. So that's how I would match those. So study, study, study for our test on Thursday.